you all students, good morning students, you all play dumb charades with your friends. And is it easy to make signs and talk to your friends and communicate? It's not that easy. So we need a medium, a way of communicating, and that medium is sound. Sound is a gift of nature which gives us ability to communicate well with others. So what we are going to do today, we will be discussing about sound, its different types and its propagation, etc. in details. Now we need to understand what is sound. Sound is a vibration. Whenever anything vibrates, it will produce sound. And vibration can travel through any medium. It can go from a solid to a liquid to a gas. It is a form of energy. Examples of different objects which produce sound are like when you are playing television, when you are using a speaker, when you are using a machine. Everything uses sound. So let us discuss production of sound. Sound gets produced when something vibrates. Vibration. What is vibration? Vibration is to and fro motion of an object. And how am I producing sound? Am I producing sound by vibrating my vocal cords? So sound is always produced by a vibration. Next is how sound moves. You are able to listen to me. So the sound is moving from the source of propagation or source of production to you. So sound is reaching you through movement, through propagation through a medium. So media are the substances that transmit the sound produced by vibrating objects from one location to other. The medium through which the sound is traveling can be a solid, liquid or gas. Now whenever an object vibrates, the particle in contact with the object starts vibrating and make the adjacent particle vibrate and continue till it reaches the other point. The point from which the particle is first displaced is called equilibrium position. So the object was in equilibrium, we displace it, so it starts vibrating. Now how do this propagation happen? The propagation of sound happens in the form of a wave. A vibratory disturbance in a medium carrying energy from one point to another without a direct contact between the 2 points is called a wave. While this disturbance of the medium itself does not happen, only the particles of the medium vibrate, and the particles do not change their position. They just exchange the energy from one particle to other. Now let us discuss waves in little detail. So we have two kinds of waves, longitudinal and transverse wave. It seems ambiguous. Let's understand what is longitudinal. Longitudinal waves are waves in which particles move back and forth in the same direction in which the wave is moving. Now when a longitudinal wave gets transformed, like you have a string, you are pulling it and releasing it. So the back and forth of movement of the wave is called longitudinal wave, and the regions in which the particles are coming closer is called a compression, and the region in which the particles are moving apart is called a rarefaction. Now this kind of wave can be produced in all the three kind of media. It can happen in a solid, in a liquid, in a gas, and sound actually moves by means of a longitudinal wave, and therefore sound can get transferred or can move in all the three kind of media. But when we consider the other kind, the transverse wave is the kind of wave in which the particles move up and down, perpendicular to the line of wave propagation. Now that is not possible in a solid, because in a solid you don't see the solid surface moving up and down, and it is not possible in the inside a liquid also, and therefore transverse waves cannot travel through all the three kind of media. And for transverse wave, we have the example of light, which is an electromagnetic wave. But we will be discussing about transverse waves in details in higher classes. Now in class, we have to discuss only about longitudinal waves. So when we consider longitudinal waves, like you have a long slinky, the regions where particles are closer, the particle will have a higher pressure. So that is a compression, and the regions where the particles are farther apart, it is a low pressure region, that is a rarefaction. So when we consider a transverse wave, as I was discussing, you can only have it when on the surface of a liquid or through a gaseous medium or in a vacuum. So when you throw a stone in water and you see the ripples of the sky getting formed, that is a transverse wave. And when we consider transverse wave, the region where the particles are getting displaced higher above movement, that is called a crust, and lower displacement is called a trough. So this is the graphical representation of a wave. Now when we graphically represent a wave, we can say the maximum displacement on the either side of equilibrium position is called amplitude. The regions where particles are closer, that is compression. When we depict it on the waveform, it looks like the crust, so we call it as the crust. The lower region where the particles are moving apart, the low density, low pressure area, is called the rarefaction. Now that rarefaction looks like a trough, so we call it a trough. And the distance between two consecutive rarefactions or two consecutive compressions is called the wavelength. So we have discussed till now that sound is a mechanical wave. It needs a medium to travel, and the medium can be solid, liquid or gas, all the three. Now let us quickly discuss the few characteristics of a sound wave. Sound wave can be characterized by these factors which are known as frequency, amplitude, speed, wavelength and time period. Now what is frequency? Frequency is the number of occurrences of a repeating oscillation per unit time. The number of counts of compression and rarefaction per unit time. It means actually is the number of time an event happens. If I am banging the table, how many times do I bang it in a second? If I am banging it say 10 times, so the frequency will become 10. Frequency is the number of how frequently the event is happening. Now since it is dependent on time, frequency is related to time period, and frequency is given by 1 upon the time period. Its unit is hertz. Now when you listen to music, if there is only a single frequency, then it is called a tone. And if it is a music where the frequencies are repeatedly changing, it is called a note. Now when we consider amplitude, I've shown it to you in the previous wave diagram also, that it is the maximum displacement of the particles from the equilibrium position. It is measured in meters and represented by a letter capital A. Now when there is a disturbance, it is moving from place of origin to another point, then the disturbance will have a speed. So speed is the distance traveled by the wave in 1 second, and it is called speed of the wave. The speed of the wave is represented by a letter V. It is SI unit is meter per second. Now we know that distance covered and time and speed are interrelated. So speed is distance upon time. Now wave speed is the distance, which is the wavelength, upon the time. And we have already discussed that 1 upon time is the frequency. Therefore the formula wave speed is equal to wavelength multiplied by frequency. We'll quickly revisit what is wavelength. Wavelength is the distance between two consecutive crust or troughs. It is represented by a Greek letter lambda. It is SI unit is meter. Time period. Time period is the time taken to complete one oscillation and or two consecutive compression or rarefactions. It is represented by a letter capital T. It is SI unit is seconds, and frequency and time period are interrelated. As we had discussed, frequency is equal to 1 upon the time period, the inverse of the time period. Now these are all measurable features of a sound. Next is we need to discuss the features which we observe, physical features. Now one of them is intensity of the sound. The amount of sound energy passing through a unit area is called intensity of sound. And loudness of the sound is the response of the ear. If I am shouting at you, you will say, ma'am, please talk softly. So loud sound will have higher amplitude. Soft sound will have a lower amplitude. Now, if the sound is traveling through different media, we have discussed it goes from solid to liquid to gas. It can travel through all the three. Then it will have speeds also, different speeds also. So speed of sound is actually depending on the properties of the medium. The speed of sound is faster in solid because the particles are closely packed, and slower in liquid because the particles are further apart, and in gases it will be the slowest because the particles are very far apart. The speed of the sound is also dependent on the temperature of the medium. If the temperature will become high, the speed of sound will also change. Now, another thing you might have observed, at times there is a supersonic aircraft going in the atmosphere and you hear the sound while sitting in your bedroom also. So that is actually sonic boom. Sonic boom is an explosive noise caused by the shock waves from an aircraft or any other object which is traveling faster than the speed of sound. So if any object is moving with more than the speed of sound, then there will be a sonic boom created. Next comes, if sound is an energy, it is a form of wave, then it will get reflected back also. You play with the ball, it hits the floor and it comes back to you, it bounces back. Similarly, when sound wave strikes an object, a surface, it bounces back. Like water waves, when they will hit the shore, they will come back. So reflection of sound is the bouncing back of sound when it strikes a hard surface. And whatever are the laws of reflection of light which we have studied, angle of incidence being equal to angle of reflection, incident ray, reflected ray are normal, all lying in the same plane. The same laws of reflection are applicable to reflection of sound also. And sound will be reflected well by the hard surfaces, and the porous surfaces will absorb sound. Now, where do we actually observe this reflection of sound? Whenever we hear an echo. Now, echo is the repeated reflection of, it's the repetition